So I was originally going to do this on a field called nuclear semiotics, which to me is one of the most interesting fields out there. If you don't know what it is, it's basically how we try and explain the dangers of nuclear waste to people after an apocalypse, so after like a nuclear war or something like that. Problem is, that hasn't happened, and since psychology is a science, we need to base everything on real facts, which is why this video is about cloning. Yes, cloning. I know how that sounds, just work with me here. This video is going to be kind of loosely structured into 3 chapters. The first is going to be explaining the different types of cloning. The second is going to be explaining exact cloning, or the idea that we have of how exact cloning might work, based on certain biological examples that we have. And the third is going to be explaining the coin flip theory. If you've never heard about that, let me give a quick explanation before we go into the deeper dive, because it should help things make sense, and it will help give you a brief understanding that you really need for this. So the coin flip theory is an idea that came about in exact cloning, mostly through science fiction, but there are some real precedented models that we'll talk about later. The idea is that if an exact scan of you, 1-to-1, was made and printed, there would be a 50% chance that your uninterrupted stream of consciousness would end up in that new clone body. This isn't true. This is pseudoscience. Remember, psychology is a science. We study the brain and mind together. We need to approach problems like these using scientific methods and critical thinking. If you didn't know, humans have actually interacted with the idea of cloning since about the start of the agricultural revolution. Plants have a process called cutting. Simply, this is a safety mechanism made for if a plant gets damaged, any part of that plant will try and grow a new plant. Simple as that. Odds are you've interacted with this without ever actually realizing it. In fact, you've probably eaten a clone without ever realizing it. If you've ever gone to the supermarket and bought bananas, then you've been eating clones your entire life. This actually does have some very real problems, though, and this is where I tell you that one annoying cousin that you have every Thanksgiving that would go, "The reason why banana-flavored things don't actually taste like bananas is because the version of bananas that they were based off of has gone extinct." Kinda. They haven't fully gone extinct. We can still grow them. It's just not smart because they're still susceptible to that parasite. Can you see the problem? They're all clones. So that parasite only needed to go through enough, evolutionary stages to affect one single plant instead of an entire group of plants, or an entire group of the same plants but of different genomes. That's why all those bananas are gone. It's actually affecting new bananas too, because remember, they're all clones. They're a different species, but it's a different species of exact clones. It's only going to take that parasite, maybe 50, 75 years to adapt. We've already seen it happen. I've said the word bananas too many times. It doesn't even feel like a real word anymore. So let's talk about the far cooler version of genetic cloning, which is animal genetic cloning, besides, worms and sea sponges. The kind of patron saint of genetic cloning is Dolly the sheep. You probably know her. She got brought up once in your science class and then never again because, you don't really need to know about it, but it's cool. Dolly was made through a very complex sounding but easy in practice process of extracting cells, turning those cells back into stem cells using a very complicated process that I'll put up here, and then causing those stem cells to replicate a sperm cell. And then, sperm, egg, you know how that all goes. This process has actually become so refined that you could have a Dolly of your own. There are companies out there that will charge a very, 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 very steep fine, we're talking like a new very nice car fine, to clone one of your pets through obtaining a genetic sample. They will give you an identical copy of your pet, but it won't have the same personality. This is mostly an exaggeration, obviously, but not quite. They need a large amount of cells to do this process with in case something goes wrong. And it's not exactly an uninvasive procedure to get that flesh sample. So once your dog, or in my case, substitute, has been stuck with a needle, the cloning process can truly begin. Remember, a genetic clone is purely genetic. Your new cloned dog won't remember you. It won't remember the smells of your house. It won't remember your children. It won't remember anything because it is just a one-to-one clone of its genetics and nothing else. This aforementioned lack of the original personality is actually why you can't clone humans. That and it's illegal. But a genetic clone of a human would basically just be their pure genetics and nothing else. You would be creating a fully grown adult with the mind of literally nothing. Also, as a fun fact, I can't be genetically cloned anyways, because I'm
the yo-yo bozo!
So this brings us to our final, and in my mind, most important version of cloning that we're going to talk about, which is exact one-to-one cloning via a copying of the brain and mind. There is, of course, a problem with that. The human brain is one of the biggest and most complex computers that we have ever encountered. Ignoring how egotistical it is for the brain to call the brain complex, it's true. The closest thing that we've ever gotten to digitizing a human is digitizing a fruit fly, and that took 100 terabytes of storage for a full mapped out digitization. It's an amazing tool that we have, but that's nowhere close to a human. Finally, after all this time, we can talk about the coin flip. Remember, this is a very out there question. But we are scientists. Psychology is a science that is the study of the brain and mind together. We use critical thinking, and we will approach this using critical thinking. The coin flip idea, as I mentioned, comes up mostly through science fiction. I think the earliest I know of that it ever comes up is the whole idea of the Star Trek teleportation paradox, which is Star Trek teleporters don't work by poofing you from one place to another. It atom by atom deconstructs you and then reconstructs you. Are you still the same person? Yes, the ship of Theseus, if it could talk, would say that it's the same ship because it's the same ship. A person isn't going to say that they're a new person. You're a clone or a copy, yes, but if everything is still there, nothing matters. This leads us to the kind of branch from the teleportation paradox that is the coin flip. The problem is there is a digitized mind and the same original mind. There are now two states of the same person. The coin flip states that there is a 50% chance that your track of mind, so the camera perspective of your life that you have had for your entire life, follows over to the clone. Obviously, this is not true. If you stuck a piece of paper into a copying machine, you now have two copies of the same piece of paper. But there's not a 50% chance that the paper that you copied is suddenly the original paper. Remember, the whole point of this project is to talk about things that take psychology and misconstrue it and use it to explain fake ideas. That's the problem. It's misinformation. I can't give you a APA-cited study that says that the coin flip is wrong. But using critical thinking, you know it's wrong. If you copy a piece of paper, there's not a 50% chance that it's the original. If you copy the brain of a human, there's not a 50% chance that it's the original. That's just sound critical thinking. The point of science is to better the world and to stop the spread of misinformation. And we are scientists. That's it. This is misinformation using science, therefore it must be stopped. Simple as that. I had some more stuff that I wanted to put into this video, but I had some trouble getting it into the 10-minute time constraint, so here we are. I don't really mind. That's kind of what happens when you talk about a subject that you're really passionate about. You end up going on tangents and rambling, and you want to bring up everything that you can, but yeah, that's it. I really hope you enjoyed. Thank you for watching, And yeah, peace.